In this video, I'm going to talk about isotopes, what they are, and how to do calculations for atoms that are considered to be isotopes. So an isotope is going to be an atom in which you change the number of neutrons in the nucleus of that atom. Okay, we can't change the number of protons because that would change your element. And we haven't talked about electrons yet, but we can change the number of neutrons that are located in the nucleus of an atom. And when you do that, you create an isotope. And really what you're doing is you are just changing the mass of that atom. You are not changing anything about the chemical behavior of that atom because the chemical behavior is based on the number of electrons, which we are not changing at all to form isotopes. Okay? Now remember that the two items or the two parts of an atom that make up the mass are the protons and the neutrons. And if we're not touching the protons at all, because we don't want to change the element, but we change the number of neutrons either by adding some or removing some, then we are just simply going to change the mass because neutrons make up about half of the mass of an atom. Now there's a couple of different ways to write out an isotope. You can either write it with the name of the element dash the mass number. Okay, remember the mass number is the protons plus the neutrons. So chlorine 35 is telling you that you have an atom of chlorine, so you could figure out how many protons and electrons are in that atom. The 35 is telling you the mass number, because remember that the mass number is not provided on the periodic table. You only get the average atomic mass, which takes into account all of the different isotopes for an element, and it averages all of those masses out to give you that decimal that you see on the periodic table. I have to provide you with the information either to calculate the mass number for an atom or give you the mass number for an atom. It's not just something that you can look up, okay? So we are going to add on the mass number to our name of the isotope so that it is clear what that mass number is. Otherwise, you wouldn't be able to find it, okay? And this is the way to differentiate between all of the different chlorine atoms is you look at the isotope names and you can see the difference in the mass numbers, and then you can tell the difference between the atoms. So you can write the whole element name like chlorine-35. You can write the symbol, so chlorine is Cl-35, or you can write it in what we call isotope notation. Isotope notation looks like this. You have the element symbol here, and then you have two numbers on top of each other. The top number, as you might recognize, is the mass number, and the bottom number is the atomic number. Okay, and I have a whole slide for this in case you wanted to write it down, but it's the general formula is that you have the element symbol large, and then you have the mass number on the top and the atomic number on the bottom, just like both of these. And you can provide that to someone or in a report, and they can understand exactly what isotope you are talking about if you didn't want to write it out as like chlorine-35. Okay? Now to practice, right, we can do the same particle calculations that we did in the last class period for regular atoms, but we can make it a little bit different for isotopes. Okay? The one thing that you notice is a little different is that there's an extra column all the way over to the right called isotope notation. You will be asked to not only write a given isotope in isotope notation, but also be able to use the isotope notation in order to figure out the rest of the numbers in the table. Okay, you will see it both ways. You'll see the isotope notation, which is the symbol with the two numbers, and you will also see it as the symbol or the name dash the mass number. So we're going to go through a couple of examples, and then you can use what you learned in this video to do some examples on your own. So for the first row here, we are given C-13. Remember the 13 is going to be equal to the mass number, but we're going to just start with the basics from what we learned last class. We know it's carbon, right? And so if you look at carbon on your periodic table, you know that its atomic number is 6. And you should also know that because the atomic number is 6, that the number of protons is also 6. Atomic number is equal to the number of protons, and it's also, for now, equal to the number of electrons. So we have 6, 6, and 6. Now I said before that the mass number is 13 because that is provided to me in the symbol. There would be no other way for me to figure out the mass number if it was not given to me in the symbol, unless I was also given some of these numbers in here. So I know that the mass number is 13. To find the neutrons, just like when we were calculating this for regular atoms, we take the mass number minus the number of protons to get the number of neutrons. So 13 minus 6 would give us 7 neutrons. Next, we need to write this in isotope notation. So remember, isotope notation has the symbol. So we're going to put a C with the mass number on top. In this case, it's 13, and the atomic number on the bottom. In this case, it is 6. So this is the correct way to write the isotope notation for carbon-13. For the second row here, we are given the protons and the mass number. Let's start with the number of protons that you should automatically know is also equal to the atomic number, as well as the number of electrons. We can also then find the number of neutrons by taking the mass number of 18 minus the number of protons. So 18 minus 8 will give us 10. We can then write the symbol for this element. Looking at element number 8 on the periodic table, you know that it's oxygen. So we're going to write O dash our mass number, which is 18. So we get oxygen 18. And then to write this in isotope notation, you put the symbol O with the mass number on top, which is 18, and the atomic number on the bottom, which is 8, to give you this isotope notation. For the third row, we are given the number of electrons and the number of neutrons. Remember that the number of electrons is also equal to the number of protons, as well as the atomic number. So we have 17 and 17 for those. We can also get the mass number here by adding together the protons and the neutrons. So 17 plus 18 will give you 35. For our symbol, element number 17 is chlorine, and our mass number is 35. So we will get a symbol of Cl-35. Again, you say this chlorine 35. You want to say the dash. And then to write this in isotope notation, we are going to write Cl as our symbol, put the mass number on top, which is 35, and the atomic number on the bottom, which is 17, to give us this isotope notation. And that is all we are going to cover today, just the basics of isotopes, what they are, and how to do the calculations pertaining to isotopes.